to this week's Unikernel application spotlight. Today we're looking at Timeplus Proton. So Timeplus is the company, and Proton is the streaming engine that we're going to be looking at. Essentially, this allows you to do streaming query processing. So if you think piping data in from like Kafka and maybe out to another database, but during that time period you're going to transform it or do other interesting things on, that's kind of what it's for. If you scroll down, basically, as user-defined functions, multi-joins and so forth. And what caught my eye and made me investigate more was it's one binary. So it's one binary written in C++. There is no JVM, which is great. No offense to JVM folks, but this just, it fits really well. So as soon as I saw it was C++ single binary, I just dived in and I wanted to see how easy it was to run as nanos. So they actually have quite a lot of nice little features, and the showcase page might jog your head for sample use cases that you might use in your company, or if you're just fooling around. So yeah, great docs and so forth. This is our GitHub repo, and they kind of go over some more of the benefits here. And so we're going to show you some examples, but first let me show you the package itself, how I went about making it. So yeah, I guess the first thing to show is I did have to stub this out in nanos, this R limit and proc. And basically what this does is it limits the number of processes that can be allowed on a system when you call fork. Obviously nanos doesn't really support fork, and it's not even really used, but I needed to stub this because this would prevent a potential fork call from actually happening. The reason why this was getting called was it was coming from a different R limit usage, but that was being used in PR limit 64. And so that's essentially what was causing the exception. 3 lines of code. So we're going to come up with a better solution. We'll put that in nanos, but that's kind of how that works. Next up is the package. So I did have to stub a few files. So I did my Etsy mtab. I literally just copied that over from the host. Again, these are libraries that the authors are using that are expecting some of these to exist. But in general, you can just stub them. Proc, we did statim. Again, I just stubbed that. You really don't need it because the way that some of these calls are being made, they don't even really read the values, right? This is somewhat common sometimes. All right, so we got that, and then let me show you. Well, maybe I could show you the config too. Okay, yeah, so there were some changes in config. I set the Proton Watchdog to enable. So they do have one call to fork. I lied. And this basically disables this. I think, if I was active in this code base, I would refactor this not to have it done this way. To me, this is a daemonization deal. But, to each their own. And then also this path was being set. You need a minimum base volume size. I just chose a gig. Choose whatever you think is good. You don't need this core dump limit. When I was diving into the R limit stuff, I thought it was a different R limit that was getting hit, and that wasn't the case. All right, so now let's go ahead and pop it up. I made my package. So like most of these tutorials, it's just under my name, Ivory Proton 1614. There's a few more ports than the ones that I've opened here that they expose. I think they expose like 6 or 7 by default. Obviously, this is all configurable, but you pop it open, and as you can see, it's immediately up and running, which is awesome. This fits really well into Unikernel ideology, at least my Unikernel ideology. And then you get this Proton client. So it's the exact same binary that I'm using, by the way. In fact, you can kind of see some other stuff that they have, but we're just going to use the client, and on the left we're using the server. All right, so now we're into the client. Gives us some warnings because I didn't really up the resources on like a prod deployment. Obviously you would want more. And then we can just go ahead and create some random fake data. So this creates a stream of devices which outputs temperatures. So we create the stream, and then we can kind of collect that data. And so this kind of shows you how this type of query engine actually works. As you can see, our fake data is getting mutated live, and we're streaming the results. It's unlike your typical OLAP databases where you do a query, you get your result, you're done. This streams the data, and so it's very useful. So if you ever use like something like Flink, this is an alternative to that. As you can see, this is any sort of streaming data use case. This is like where you're going to get a lot of juice from. But yeah, that was the quick little demo of running the Timeplus Proton data storage engine as a Unikernel. So till next week.